Hello everyone, Ismail is here. Today we're going to start with the logarithmic function 3.2 in the chapter 3. Okay, what we are going to learn in this function, or in this lesson we are going to learn about evaluate expression involving logarithm, and we are going to learn how we can sketch and analyze the logarithmic function. Okay, now let us start with the first thing about logarithmic function and what's the difference between logarithmic and exponential. As we know that the exponential function is the function that has a base of a number and a power with the variable. Means a base 5 to the power of x, or 10 to the power of x, or whatever, 5 to the power of y. So this one is exponential function with the base of a number. Now, what is the logarithmic function? Logarithmic function is the inverse of the exponential function. So the inverse of the exponential function, it will be the logarithmic function. So if you check here in the black color, the black color represents the exponential function, which is at the center of the graph is 0 and 1. Okay, and it should be b to the power of x. And as you can see here, the logarithmic function is opposite to the 0 and 1, and it will be 1 and 0. So this one is the logarithmic function, which is the inverse of the exponential. So it will be log base b. Okay, so as you can see, the base here will be the base of the log, and the power of the x will be the x here, as you can see. Now, let's look to the key concept that we see here. So how we can convert between logarithmic and exponential? How can I switch between them? So as you can see here, when I have, for example, let's start with the exponential. So the base of the exponential will be the base of the log. So, so for example, if I have 5 to the power of x, so how can I write it as log? So it will be log, okay, base 5 and x. So this is how can I convert from the exponential to logarithm. Now, for example, how can I convert from log to exponential? So the same thing. For example, let's say I have log 5 and here x equal 6. So the same thing happens. So I take the base here is 5 and the equal here is 6 equal what? Equal to x. Okay, so this is how can I solve and convert from exponential to logarithm. Now let's start with the example here, how we can evaluate each logarithm. So to evaluate the logarithm, as you can see here, so look to the first example. Look, base is 3 equal, or let's say x is 81. So the first step number 1, okay, we equal with y. So we equal this part with y, as you can see. This is the first step. Step number 2, what's happening from here to become to this one? We convert. Step number 2, convert to exponential. So how can I convert to exponential? As we know that the base here will be the base, and the equal sign will be, let me write it here. So the base will be the base, and the equal will be the power, and the last one, the x that I have, will be after the equal. So this is how can I convert from log to the exponential. Now after that, step number 3, well, you have to look to the big number and change the big number to be same as the base. Okay, so step number 3, look to the bigger side and equal the base. Okay, so let's write it here, equal the base. Okay, and the base here is a 3, so I have to change this one to be 3 to the power of something, okay, that equal that 81. So 3 to the power of 4 is equal 81. So now after I have number 4, which is the last step, cancel, okay, cancel the bases. Okay, we don't need, and take the power. So we cancel the bases, 3 with the 3, so it's remain y equal 4. So this is the answer. We can do this one using calculator fast, but if the question asks me to evaluate using show me the steps, so I have to do this one. Now let's do question number B. So the same thing, as you can see here, we have a rules that when I have a square root of anything, for example a, so how can I convert this one to exponential? So it will be a m over n. So as you can see, what's the number here? It's square root, so always 2. And here, what's the number is 1. So let's convert it now. So log base 5 5 to the power of 1 over 2. Now, as you can see here, I have the same basis and the same thing. Now, step number 2, we are going to go with the, So step number 2, we are going to go with equal with y. Equal y. Okay? Then we converted. Step number 2 here is exponential. Convert to exponential. So we take the base. So the base is 5. And we take the power. Power is the equal. And equal to the x's. The x's is 5 to the power 1 over 2. Now, as you can see here, I have the same basis, so I can just cancel the basis, which is y equal half. So this is the second question. Now, question number 3. Same thing here. So first step, equal with y. Log 7, 1 over 49, equal with y. Then after that, I convert it to exponential. 7 to the power of y equal 1 over 49. Now, look to the big basis. The big base is 49. How can I convert 49 to become the same base of the 7 to the power of something? So it's 49 means 7 to the power of 2, right? So now let me write it. 7y equal 1 over 7 to the power of 2. Then we have the way that we know that if I have 1 over a to the power of m, I can flip to become of negative. So this is a rule. So now 7 to the power of y equals 7 to the power of negative 2. Now, do I have same bases? Yes, so I cancel the bases. So y is equal negative 2. This is how can I solve the question. Now, it's your turn. Try to solve the question here, hidden here. I wrote them to you, okay? And if you need any help, please let me know. And these are the answer. So after you finish solving, you can check the answer that you had, okay? To see that are you doing well or you need more help, so you can ask me. Now, let's go to the next part. Let's do the basic properties of logarithm. As we can see here, we have here the basic property. The basic property, the first property for this one, when I have the base b and x is 1, when x is equal 1, so the answer is always 0. So for example, let's say I have log 5, 1. So what is the answer will be? 0. Always when I have x is equal 1, always the answer is 0. Then, number 2 here. When I have the base, same as the x is always equal 1. So log, for example, I have 4 here and x is 4, so the answer is equal, always 4. So when the base and the x are equal, so always is 1. The next one is the power. When I have the base, same as the x, when the base same as the x, so the answer is always the power. So when I have log, for example, 6, and here 6 to the power of 2, so the answer is equal 2. Now, the last one is the inverse. So as you can see here, the inverse, when I have, for example, b to the power log base b, so when the base here, same as the base of the log, so the answer always is equal x, that's it. So for example, I have 10 log, 5. So the answer is equal what? The answer is 5. Why? Because the base here is 10. Now, let's take example here about this one to understand more about the properties. Now, evaluate each logarithmic expression. Log 5, 125. Can I convert 125 to become as the base of the 5? Yes, I can convert it. 5 to the power of 3, right? So log base 5 and 125 can be 5 to the power of 3. So as you can see, because of the rule that we have b and b to the power of x, the answer is always equal x. When I have the base same as the x here, so we take the power. So here the base same as the x, so the answer is equal 3. Now, question number b here. So as you can see, this is the inverse. So as you can see, the base same as the base, so the answer is always x. So the answer is equal 4.7. Now, how about this question? What do you think? This one is easy. 81 can be 9 to the power of 2, right? So, because 9 over to the power of 2, so the answer is equal 9. How about this one? Easy also, it's equal 1. Now, let's take the common logarithm. So we have here the common logarithm. So just to summarize it, when you have log without base, we don't know the base, and they just tell you log base log 5. So that's mean log is base 10 5. So what we call the log here, that we call it common logarithm. What is the common logarithm? A common logarithm is a logarithm with the base 10 or log 10. So this is the meaning of common logarithm. So every time when you hear common logarithm, it's the same when the base of the log is equal 10. Now let's solve this equation. So as you can see here, the first question, evaluate the expression. Log, we don't have a base, so of course the base is equal what? 10. Now when I have the base 10, I need to change this one to be similar to this base. How can I change this one to be similar to this base? 0.0, if I move the decimal, okay, I have an option to move the decimal 1, 2, 3, and 4. So I have a decimal, I have a way of moving to make it as this one here. So it will be log base 10, and I move the decimal 1, 2, 3, 4 to the right. So I mean 10 to the power of 4 equal negative 4. So now I have the base same as the number here, so the answer is equal negative 4, using the rule that we already learned when I have b to the power of x, so the answer is equal x. Now question number 2, here, question number b, sorry. So same thing, what's the base for the log? It's 10. So when I have the base 10, similar to the base of the log 10, so the answer is equal 5. Easy. Now how about this one? Log 26. So I have here log and the base is 10, 26. Can I simplify this one? 26 cannot be simplified to this one. No, I can't. Even if you use the y, so let's equal with y and convert it to exponential. 10 to the power of y equal 26. Okay, so how can I convert 26 to be similar to the base of the 10? Or 10 can be similar to the base of a 26. How can I do that? You can't do this except using the calculator. So you can use the calculator to solve this equation. So it will be 10y equal 10 to the power 1.42. So y is equal 1.42. Okay, just an approximate. Okay, so let's make it as approximate. So now the last one, log is negative 5. As we know that always the x should be greater than 0, and x also, okay, we don't need the log is equal 1, because we know that if x is equal 1, the answer is equal to 0. Okay, so we don't need x is equal 1, and we need it always greater than 0. So all the negative value are excluded. Okay, so the negative value are excluded. So this one is undefined. Now try to solve this equation here in this area, and it's the same rule, but as you can see, all the question without the base of without number of the base for the base, so the base always follow the same step, which is the base is 10. Now the last one is the natural logarithm. The natural logarithm here is following the exponential one, okay, or following the e base. So the base e, as you can see, it's always with the ln, because we know that the log x, what's the base of the log? It's 10, right? Now the same thing for the ln e. Ln e is always equal to 1. Why ln e is always equal to 1? Because let's go back to the log little bit. One of the properties of the log, okay, when the base and the x are equal, the answer is equal what? The answer is equal 1, right? So the same idea. So just quick example. So if I have log, okay, 10 and 10 here, what is the answer? Is equal 1. So the x and the base are the same. So of course the answer will be 1. Here the same idea for the ln e. The ln, okay, and the e together, they are, let's say for example, the same thing for the base and the x here. So when I say ln e, it's similar when I saying log base b to the b. So it's equal 1. So both of these are similar to each other, which is, for example, inverse. Okay, so that's why the answer is equal 1, and len is always related to the e, or to the base e. Now, okay, let's go to the properties here for the base e. For example, the first one, it's similar to the log. So when I have len 1 is always is 0. So any len is equal 1 always is equal to 0. Now, len e is equal 1, similar as I told you, because we have the base of the len, e is always is equal 1. Number 3, when I have the same thing, when I have len e, the power is my answer. So for example, len e to the power of 5, so the answer is equal 5. And the same thing for the exponential. So when I have e to the power of len, okay, this one is similar when I say 10 log 10, okay, equal, let's say for example 5, so the answer is equal 5. So len e to the power of len 5, so the answer is equal 5. Okay, I hope you understand the rule. Now let's go here and take some examples about the natural logarithm. So the natural logarithm is, first one is 0.73 e to the power. So as you can see, len e, they cancel each other, so we take the answer, which is 0.73, and here is undefined. Okay, it does not exist because it's negative, because always x should greater than 0. And here when I have e to the power of len, the answer is equal what? The answer is equal 6. And len 4, so how can I solve len 4? I can't solve len 4 until I use the calculator, so I use the calculator for that. Len 4, it's equal 1.386 maybe, so the final will be 1.4. Okay, now let me show you the answer for the question here. So the first one, len 32 is about 3.47. E to the power of len 4 is equal 4. Then this is negative 3. Then the last one, negative len 9 is equal negative 2.20. Okay.